last video, we solved basic differentiation problems using power rule and chain rule. Today we are moving a step further, focusing on quotient rule, which happens to be a powerful tool for differentiating functions written as one expression divided by another. Let's get started. Let's start with question 1c. As we can see here, this is a function where we have one expression being used to divide another expression. What we have here is a polynomial and the denominator is a trig function. So we are going to use a variable u to represent x squared and a variable v to represent sine x. That is the common variables that is usually used when applying quotient rule. Let's see how to go about it. Let u be equal to x squared and let v be equal to sine x. Our dy dx equals v du dx minus u dv dx divided by v raised to power 2. Now, from what we have here, we already have an expression for u and we already have an expression for v. So what we only need from this formula we have here is to derive du dv and is to derive du dx and dv dx. So this is differentiating u with respect to x for this, and for this one, this is differentiating v with respect to x here. So if we differentiate our u with respect to x, that is du dx, that gives 2x, and our dv dx here, our dv dx will give us, when you differentiate sine x, it gives cos x. So that is under the derivatives of trigonometric functions. Now, let's substitute these expressions in our formula here. It's very simple. Our v here is sine x. Our du dx, we are going to write according to what we have on the formula. So our du dx from what we have here is 2x. So let's put this into brackets. So this is our du dx minus our u is x squared. Let's have x squared here, and our dv dx is cos x. So we have this in brackets. Then we have dv dx here as cos x. So we divide everything. We divide our whole function by v squared, and our v here is sine x. So we have sine x all squared. So let's try to simplify this further. When we are to remove the brackets, multiplying 2x and sine x will give us 2x sine x minus multiplying this and this will give us x squared cos x divided by, and when you are having sine x raised to power 2, it can also be written as sine square x. This is very very similar. This and this are the same thing, but it is usually written as sine square x. So we cannot simplify what we have here. We cannot simplify it further. So therefore, this is our final answer. It's as simple as that. Now, let's move on to question 4a, which happens to be very similar to question 1c that we just solved now, except for the fact that here our numerator here is an exponential function, while the denominator remains a trig function. So, but we are still going to use quotient rule because this is a function where one expression is being used to divide another expression. So we are still going to use quotient rule. Let's see how to apply that. Now, let's u be equal to a raised to power x, and let v be equal to sine x. So we use this to determine the u, the x. Now when you differentiate an exponential function like this, it gives you exactly the same thing. So e raised to power x will still give you e raised to power x when you find the derivative. Then when you take the v dx, that is differentiating sine x, what we have is cos x, as we can see in the previous example, or in the previous solution. Now let's find the y dx. So for the sake of managing the space on the board, I may not write out that formula for quotient rule here. So we are still going to make use of the same v du dx minus u dv dx divided by v squared. That is how we apply quotient rule. So here we have our v here. Our v here is sine x in brackets multiplied by du dx. That is v du dx, which is e raised to power x minus u, which is e raised to power x, multiplied by dv dx, which is cos x. Then we divide everything by v squared, and our v here is sine x. So we have sine x all squared. Now let's remove the brackets. So here we have e raised to power x sine x. So it is usually decent to write the exponential function before the trig function. If it is a polynomial as well, it is always more decent to write the polynomial expression before the trig expression. So we have e raised to power x sine x minus, in this case as well, we have e raised to power x cos x, everything divided by sine square x. But as we can see here, we cannot leave this answer like this, because if you observe this expression very well, you will discover that we have e raised to power x being common on your numerator. This is common here, so therefore we need to we need to use e raised to power x to factor out that expression. So because this is common, you can just have your e raised to power x into brackets. So when you are using that to factorize that expression, what you are left here is sine x. So we are left with sine x here minus, then here we are left with cos x in brackets. Then you can use that to divide your denominator, which happens to be sine square x. So this is going to be your final answer. So these two questions are great examples of how to apply the quotient rule, even when the functions look different. Whether it's a polynomial or an exponential function or a trigonometric function, as long as we are using one expression to divide another expression, the go-to method is always the quotient rule. Thanks for watching. This video is part of our ongoing series in solving key trigonometry and calculus exam questions. In the next video, we will continue with more derivatives of trigonometric functions, making use of quotient rule, product rule, and chain rule. So in that video, I am going to make a very simple clarification of where to make use of the quotient rule, the chain rule, and the product rule. Subscribe and hit the bell to stay updated.